discuss about the changes that we want to incorporate from this semester in our learning process. Probably you know the what do you call education paradigm that we will be using from this time ahead. The name of this thing is outcome-based education. Have you heard about this thing?
No, sir.
So your university is planning to implement that OBE-based education in our system. For this reason, we have to prepare ourselves, but before that, we need to know about the system first. Actually, this is a student-centric education system where the conventional delivery and evaluation will not be made. Okay, we are planning to give you the course outline in a form that corresponds to our OBE. In your OBE-based education system, as it is outcome-based education system, what you need to do. Okay, conventional simple course delivery, course evaluation will not be the case. Okay, every program will have some program objective or program outcome, or sometimes called student graduate attributes. When a student will graduate from that program, he will acquire those attributes. Then he will become a professional engineer, and accreditation will be possible. When accreditation of the program is made, then the global mobility of our graduate will be ensured, and you can work anywhere in the country, in the globe. And these become mandatory from now on, probably. So we prepared our OBE-based guideline. In each of your courses, there will be some course objective or course outcome. Those course outcome is to be acquired after completion of the courses. Then that course outcome should be mapped with our program outcome. Then at the end of your 4th year, we have to assess you that whether you have acquired this program outcome or not. In this way, our system will run. But the thing is under process. Although I have prepared my course outline in this way, but it is still not complete. Some other issues are there that I will incorporate within a day or so. And hopefully in the next class, I will explain about it a bit better. So for the time being, let us start with the conventional ways that I give you the course outline at the beginning of the semester. Okay, this lecture has been recorded by other sections. So you need not to record this thing for you. You can have this thing from them. Okay.
Yes, sir.
Can you see this shared screen?
Yes, sir.
Yes, sir.
Okay. So this is the name of your course is Signals and Systems.
Hello.
And
Sir,
yeah.
Sir, could you give the permission to record? Because
No, the recording has already been made by other section. You have to use it from them. Okay, I will be following the same content. Okay, section A recorded, section C C recorded. So you can have a record from them. Okay, because if you keep in recording, it will keep some overburden to my system. Then the network might go wrong. So, and today's class will be introductory one actually, and you will see that all things that I covered to them will also be covered here. So, our course will have 3 credits like all other, most of the theory courses. And the text that we are following, the list of the text is given with the writer. Then some of the text will be made available to you, and others you have to explore. And we will be following a text, the text number 1 as our reference, as our main text. Then all other text will be the reference text. In order to complement your understanding, you have to explore all other text. Now, Let us go to the content of the course. Okay, your course materials is uploaded in this Google Drive. I shared the link already with your messenger group. And like other course, like my previous courses, time to time I will upload the thing there and let you know. This quiz or the schedule for mid and final exam will change. I will when it will be finalized, then I will give you the exact information on it. This is your grading policy, you know it. So I will be starting from this point, the content of this course. You know that the content of this course is signals and system, and it has these topics that we need to cover in this course in order to what we call fulfill this objective that is also listed there. Can you read it? Can you see it? Can you read this thing?
Yes, sir.
Okay, you see that many things are written there. Can you find something that you have already known? For example, continuous time and discrete time signal, something like this, sampling and aliasing. For example, say your periodic signal and non-periodic one, Fourier series, Laplace transform. Have you heard those terms earlier?
Yes, sir.
Yes, sir.
Probably you have heard those terms in your communication course, in your digital electronic course, as well as in your mathematics, isn't it?
Yes, sir.
Yes, sir.
So your mathematics is Fourier series and Laplace transform. These are the transform technique that we usually use because in all engineering disciplines, these two transform technique is very important in order to characterize our system. So if we just go through this content, you will see that many of the terms are already known to you. What we usually do, we need to elaborate them and we need to apply them to some real electrical and electronic engineering system so that you will understand the thing. So with this thing, let me go to the lecture slide, okay? The rest of the thing I will discuss later about OBE, okay? And course program outcome. Okay, can you see this now?
Yes, sir.
Okay, this is what our text that we will be following during this lecture, okay? The first text is this one, Signals and System by Simon Haykin. I have supplied the soft copy of the book to you, and I will, and probably if you can access your library has the copies of this book. So for the time being, we will be with the first text, okay? Then second text is also a good, these two texts are actually very standard text followed worldwide. So our signals and system, we will study principally from this book, Signals and System by Simon Haykin. Now let us proceed with our first understanding, that what do you mean by signal and system? Can anyone define me what is a signal actually? Do you have any idea what particular thing we can call signal?
Signal is a kind of impulse that excites the system.
I cannot hear you clearly. Just put your microphone near to your mouth.
The signal is a kind of excitation that starts a process or give instruction to the process.
Okay, what I sometimes see that you guys are using, for example, when I ask question test, you are using internet. Okay? Without understanding, do not do anything, please. Okay. Can anyone define the signal in a better way from your understanding?
So it's a function to transfer information.
Actually, the thing is that when a signal term is not used by engineers only, in many of the cases we use signal. For example, say a traffic signal. What is the purpose of this signal? Just to give some visual or some other information to the drivers or the users, just in which ways he need to follow and which path he need to go and in what ways he need to drive, isn't it? That means signal is actually a physical something that signal is, for example, signal is intended for to convey some information to its user, isn't it? Then that user can use the signal directly, or you need a system to process that signal, isn't it? So a signal is actually what you have defined. Yes, it is correct that your signal is a representation of a physical phenomena that will convey some sort of information somewhere. Because if you don't have any information in a quantity, that is meaningless. So your signal, in that sense, anybody can define a signal, okay? And the nature of your signal depends on the nature of the system you are using. The electrical engineers use signal, the mechanical engineers use signal, the other discipline also use signals. Those signals are the function of actually some independent variables, and those variable can be time, can be a space, or any other independent variable, and that particular function will convey some sort of information. Okay, so if we want to define it generically, let us go to the next slide. Okay, a signal is formally defined as a function of one or more independent variables that convey information on the nature of physical phenomena. That means if we have a physical phenomena occurring, that physical phenomena can be mapped mathematically or by some other ways to a function, and that function will have some independent variable. That independent variable depends on the physical phenomena. For example, say if we want to monitor the temperature of a patient, how did we do that?
So we can use the thermometer.
We need a thermometer, and we place the thermometer somewhere in the body of your patient. Then after 1 hour or so, we can measure the temperature and record, isn't it? In this way, we can do that. Another way we can do that, we can place a sensor there connected to that patient, and we can have a device. That device can monitor the temperature continuously, isn't it?
Yes, sir.
So if we want to examine the nature of the signal in these two cases, how they will look like? One will be something like this, that if we plot them, for example, in this way, can you see this writing?
Yes, sir.
Yes, sir.
Say this is your temperature, and this is your time, and this is for, say, your temperature degree Celsius. So at, for example, one time he reached this temperature, other time he reached this temperature, it is reading this temperature in this way, isn't it? That he can do. Another way is that if we can have a device that is connected to the patient, so that if it is your time and it is continuously monitoring the temperature in this way, isn't it? This is your temperature, say degree Celsius. Now this is a nature, this is also another nature, isn't it? So what is the difference between these two? In between these two time interval, for example, say T1 and T2, we don't have any recorded, isn't it?
Yes, sir.
But if we go all the way in this case, you will see that in all time you will have a value of your temperature. Because in this way you can record your signal. That will give you the temperature variation of a patient, something like this. Even that temperature, if you have an oven, you can record your temperature. Okay, like so another signal can be, say I am talking for example. Then what will happen if we have a sound signal that is changing with time, for example in this way, then this signal, for example, should have a time dependence, and it will vary in such a way that it will convey some information to you. For example, if I make a noise continuously, will it give any information to you?
No, sir.
No, sir.
That means not all signal will or all function can convey information. The function should can be categorized as a signal when it conveys information. Okay, so this voice signal is a form of signal. Similarly, any sort of signal that we need to use for a particular purpose with meaningful representation is termed as signal. Now, its nature of a signal, it depends on in which purpose we need to process it. Okay, so generically in our everyday life, we are encountering signal, we are processing it, and we are obtaining some output from the signal. Okay, your input signal is processed by a system, then it will provide, for example, another signal. So in this way, your signals and systems are connected. Formally, your signal will be given as an input to a system. That system will manipulate or process your signal and give you an output. Okay. So in everyday, what we are encountering every day can be modeled with this simple model of signals and system. For example, if you want to cook rice, what you need to do, you have to need some ingredient. Those ingredients will be your signal. Then you need a system, a cooker, that is your system that will process, and you will have a, for example, cooked rice. That is your output. So in this way, your signal can be there. Similarly, if I want to amplify my voice, what you need to do? For example, if someone wants to amplify his voice, how he can do?
So the microphone can be used, after that speaker.
That means you need a mic first, okay? Your input is a voice pressure signal, for example, this one. You need a mic that will convert an electrical signal of similar type. Then you need an amplifier, say, to amplify your signal. Then you need another device there, say speaker, isn't it? Just to emit that sound, isn't it?
Yes, sir.
So all, for example, this thing from this point to that point is actually constitute your system. This is your system. Your system can have a single component, or it can have multiple subsystems connected together, okay? So your system will process your signal and it will give you a desired output. So in this way, we have to proceed with our signals and system. Now the question is how we will proceed, because we are not in the laboratory that we have a mic, we are acquiring the signal, then we are preparing an amplifier, giving an output, then we connect a speaker, we will hear it. So in our classroom, what we need to do, at every stage, we will need mathematics, isn't it?
Yes, sir.
We have, first of all, okay, I will discuss, after having discussing the next block, I will be going to sharing you the whiteboard. That will be more effective, I think, for you to understand the thing that we are going to deal with this course. The next system is what? Can you identify this system? Probably you have already learned this system in one of your earlier courses. Is it not a communications channel like something?
Yes, sir.
That means if you have a message signal, that message signal can have any form that convey information. What you need to do, you need a transmitter, okay, that will process your signal to make it ready to feed into a channel. So that channel will then work as a conveyance medium that will simple a conveyor that will convey your message to some other point that we call a receiver. At the receiving end, your signal will be again processed, and at the output you will get a signal. But in communication engineering general, we use a term there, estimate of message signal. So I will talk about this estimate. Now you can consider that your transmitter is a subsystem, your channel is also a subsystem, your receiver is also a subsystem. They are concatenated in this way to just constitute a communication system, okay? So at every stage you need to identify and process your signal in a way so that the other part will work. Now, when we use estimate of a message, can you tell me that why we are using this term estimate at the output?
So because there will be error.
Actually, that thing estimation means what? Some form of measurement, okay? And that measurement is not deterministic type. The reason is that whenever a message is transmitted over a channel, there exist many phenomena that can contaminate your signal, isn't it?
Yes, sir.
That contamination is sometimes we call signal impairments. If your signal is impaired or contaminated by some noise or other quantities, then what will happen at the receiver? The receiver cannot decide exactly that whether the signal is sent or the other thing is sent. For this reason, your signal should have some mechanism to identify that your signal that your signal is received. So that reception cannot be 100% correct. It will contain some error. For this reason, an estimation procedure is needed there just to estimate your signal. Otherwise, communication would not be viable. So these are the generic representation of your signals and systems and how are they connected. They can be either connected in this way, the output of one subsystem is connected to the input of another. This form of connection we call cascaded connection. But some other form of connection, feedback connection, many other topologies exist. So we will be dealing with those topologies later in our lecture, okay? Now let me share you the whiteboard just to tell you how can we proceed with this course. Okay. Now it is visible to you?
Yes, sir.
Okay. Now you see that we are considering that we have a block. That block we are calling system. That system has some architecture, okay? Then these two arrows indicate that we have an input and we have an output. Now, if we are in the class, your input should be represented by mathematics, by using math. Your output should also be in the mathematical form. Then your system should also be represented by mathematics, isn't it?
Yes, sir.
So all these three components actually need what particular thing we need actually? Math. So math is the prerequisite of this course. How many math courses you have studied so far? Probably 4 or 5, isn't it?
Yes, sir.
Some mathematics deals with differential equation, other deals with vector analysis, complex algebra, integration, differentiation, Fourier series, Laplace transform, and
Numerical methods.
Numerical methods, okay? Numerical methods. Actually, numerical methods is not mathematics. It is actually a method. That means whatever mathematics that you have learned in your 6 courses can be handled by numerical method. Why we need numerical method?
For precise calculations.
For precise, numerical method can never be precise because it needs some approximation. Actually, the
So
thing
we can
that
use the computer program to efficiently
yes.
calculate it.
Actually, the thing is that whenever we integrate something, say 0 to t, say xt dt, your computer will never understand how to integrate it, okay? What you need to do, you have to transfer this integration into a form of operation that is either plus or minus or division or something like this. That means every complicated mathematical operation will be transferred into some arithmetic operations. Those arithmetic operations are the basis of numerical method, are not they?
Yes, sir.
Did you use any other thing rather than simple addition, subtraction, division and multiplication there? No. So any problem that we have in our real life by using mathematics can be transferred into some equivalent operations represented by only these elementary mathematical operators. Some logical parameters can be there. So arithmetic and logic operations, ALU, arithmetic and logic unit of your computer is the basic unit where your computation is made. So that signifies that your computer can understand only arithmetic and logic, okay? Nothing more than this. So whatever you need to give input to your computer, that computer will simply analyze the thing either using logic or by using arithmetic or combination of these two, then give you a result. In order to do that, you have to know the physical meaning of the mathematical procedure. You know that that particular thing is what? This is an integration. Is it not the area under the curve between the limit 0 to t?
Yes, sir.
So if we have a curve, for example, t, this is you say xt. Your xt is changing in this way up to this point, say 0 to t. Then how to evaluate that integral? If the equation of this curve is known to you, you can set this equation to this integral and evaluate it. But in many cases, that equation can be complex, or even in many cases, you cannot derive this equation. Then how to evaluate that integral in this way? You know that this integration is this area. Is it not that area?
Yes, sir.
Then in many ways you can calculate that area. You can subdivide this area in this way so that each of your area element will be looking like a rectangle. Then you calculate the area of the rectangle and sum them together. That will give you the value of this integral, isn't it?
Yes, sir.
Or you can use, either you can use rectangle, even you can use trapezoidal function there. For this reason, you see in your numerical integration, you have some algorithm. And one of the widely used algorithm is called trapezoidal method, isn't it?
Yes, sir.
Have you heard about it?
Yes, sir.
Because trapezoidal representation is very closer to your signal. So you can easily calculate the area of the trapezoid, individual trapezoid, and you can add them together. That will give you the area of the signal. So in this way, you can use your numerical technique. So your numerical method is actually not mathematics. These are the methods that handles complex problem, or even simpler problem can also be handled. The main issue is perspective is two. One, you may have your system or signal that will not contain a definite mathematical function where your numerical method will be the only choice. Or if we want to use our computer, one student was saying that your computer will never understand this type of continuous analytical mathematics, that what you need to do, you have to convert them to some arithmetic and logic functions. That transformation of arithmetic and logic from a continuous analytical function is the main work of your numerical methods. That will always incorporate some error. You have to devise your method in such a way that your error would be what?
Used.
Error will be minimum. For this reason, in all numerical courses, initially students are introduced with error calculation and representation of your function in computer. Okay, have you learned about it, how to estimate the error of a numerical method?
Yes, sir.
So you know that we have our two types of error. One is called round up error, another is called
Truncation error, sir.
truncation error. Yes, and you see that these two types of error has different nature. If your step size of calculation is small, then it can increase the round up error, and if your truncation size is larger, it will again increase the truncation error. So as a result, we will see that we will have an optimum step size. For example, if you want to discretize this equation, integral equation, you have to make some step, subdivide. That subdivisional step, for example, del t, should be such that your error curve is something like this. Okay, if this is your step size, this is your error. Can you hear me? Because network is a bit unstable.
Yes, sir.
Okay, because frequently message is coming that network is unstable. So actually the thing is that you see that if your step size is lower, then it will use a error that is called truncation error. If your step size is higher, it will cause an error that is called truncation error. Okay, this is your truncation error, this is your round up error. Then if we just add them together, you will have a curve something like this. Okay, that this region is the optimum region of your step size that will give you minimum error. So in every numerical algorithm, that analysis should be made first in order to proceed with. Okay, so you know this thing. So your mathematics will be the main component of our signal sense system, because you need your mathematics to represent your signal. We can have, say, a signal in time domain xt. Similarly, we can have an output yt. Then we have to represent, for example, our system by using some technique that is also mathematical. Then we have to connect our input with the system that will give you an output. Okay, can you explain this thing from your earlier understanding of electrical circuit when I taught you in your first year? Because I have discussed this thing a bit there, how a real system can be brought in the classroom by using some mathematics. Can you remember this thing that I told you in your first year? So guys, from now on, okay, your system is OBE. Your silence will never work. You got my point? If you want to get your degree accredited, the evaluator will come you and take you viva. If you cannot respond, they will never accredit you. So everything that is discussed in the class, you have to keep note by somewhere or other and memorize it. There is no anyone who can answer this question, that how we deal with electrical circuit in first year? Hey, kotha bolo na keno? Is there anybody? Hey, are you engaged there or not, just sleeping?
Yes, sir, we are here.
If you can hear, then you have to respond either yes or no.
Sir, we can't remember actually.
You cannot remember it, but can you explore it? For example, if we have an electrical system, how do you do that? We just use some schematic to transfer it into a circuit, electrical circuit. Then what we use? We use our laws there, KVL or KCL, to form some equations, are not they?
Yes, sir. Yes, sir.
So those equations are what? Are not the mathematical equations?
Yes, sir. Yes, sir.
So these are the laws, okay? So what will happen if you have a real system? That real system, first your input should be expressed mathematically. Then you have to use that standard technique to transfer this system into a circuit. Then you apply your Kirchhoff's voltage law and current law there to convert this circuit into some equations, okay?
Mathematical equations.
Those equations, when available, those equations are sometimes you need to solve to find your desired output. So these equations are sometimes called input-output equation, are not they?
Yes, sir.
Because that equation will contains only your desired output and the input and some parameters related to your circuit. So whenever you are obtaining this equation, you do not need this circuit, okay? Your circuit is translated into a mathematical model. So that is what you need to start with from this course generically, okay? If we have an input, you have to represent it mathematically. If we have a system, you have to model it mathematically. Then you have to connect them together. How that connection will be made? That connection will be made by using laws and rules, okay? Laws and rules will be there that will connect, for example, your input with your mathematical model of your system. Then you will find an output by solving those equations mathematically. So your mathematics is the basis of this course. Now the thing is that if we want to proceed further, how we need to proceed actually, then our step would be what? We have to learn about our nature of our signal, okay? What is your signal? We define the signal generally, but how this signal will work actually. Your signal can be, for example, one-dimensional. Your signal can be one-dimensional. We call it 1D signal, one-dimensional signal, okay, or 1D. Your signal can be multi-dimensional. How the dimension of your signal is defined? Actually, your signal can be a function of one or more independent variable. The dimension of your signal is depending on how many independent variables are involved in it. We can have one-dimensional signal, say our voice signal, okay? If we want to represent our voice signal with respect to time, it is something like this, okay? It's changing in this way. So this xt is, what is the dimension of xt? It is one-dimensional signal, okay?
Yes, sir.
If we have an image, for example, say a black and white image, say this is your x-axis, this is your y-axis. How an image is created? By mapping the illumination level in a space, isn't it? If an object is illuminated by light, then if you can sense how the illumination is changing over the surface of your object, then that can be mapped into the form of a figure that is called your picture, okay? So the intensity level in this picture will vary with respect to the coordinate x and y. Then this is also a signal function of how many independent variable? 2 space independent variable. So this is a two-dimensional signal. Now, if we take, for example, the picture in successive instance of time, say this picture is taken at t1, we will have another picture at t2, we will have another picture at t3. Then if we want to examine all these three pictures at these three independent time, the 3 time instant, then you will see that the nature of your picture will also depending on your time t, isn't it?
Yes, sir.
So what will be the dimension then? If we just consider all this thing as a signal, then another dimension will be added to your signal time, okay? That it becomes a 3-dimensional one. Another issue is that if we have a color picture, say we have a color picture, RGB color, then how many things will be there then? You will have a red information, green information and blue information there, isn't it?
Yes, sir.
If these things are there, their RGB value and intensity level, all are the functions of this image. Then your image become 4-dimensional or something like this. Even the time can be added with it. If we take picture in other different time, like your movie. So this is way, in this way, your signal dimensions can be understood. In this course, we will be principally, because this is a very basic course, For this reason, we will be concentrating on one-dimensional signal only. And in our case, time will be our independent variable. In our case, all the thing that we are dealing with will involve time and your nature of your signal. Okay, in our electrical engineering, your signal can be voltage, your signal can be charge, your signal can be current, power, energy, whatever it may be. Okay, but the generic form of your signal will be used in this course. Okay, so that we can use this technique in any of our special cases. So let me go to the slide again. Okay, all the thing that I have discussed there about dimension is there. Okay, you can have a look, no problem. These are very general description. Okay. Now I will be going to this topic. Again, this topic will lead some discussion. I will discuss it, okay? Actually, your signal should first have, you have to classify your signal by using mathematics, because our representation of the signal will be by using what? We have to represent our signal by using
Mathematics.
Mathematics. So if we consider that our signal is continuous, then our signal is one-dimensional, then their signal can be real valued, their signal can be a real valued one, their signal can be a real valued one, or can be complex valued one. Okay, for example, say, if we have a signal e to the power, say, j omega t, is it a complex valued signal or real valued one?
Complex.
The signal is complex, okay? That means it will have a real part as well as an imaginary part.
Imaginary part, yes sir.
Each of your part is actually a real valued signal, okay? Now your signal can be your continuous in time and discrete in time. Okay, I will be discussing this thing at depth by using whiteboard a bit later. Just let us talk about it. A CT signal is a signal that is defined for all real values of t. That means if we have a continuous time signal that will exist at all time within the duration of your signal. We can have a discrete time signal. That discrete time signal is represented in this book by this quantity, and it will exist only at discrete instants of time. Now the rest of the thing I will discuss using the whiteboard, okay? And you can have
Okay,
your other topic there will be covered inshallah within this discussion. Because Blackboard and writing is the most important way to give the deliberations, okay? Because your simple discussion will not help. Look, our discussion was we have a CT signal continuous time, we have a DT signal discrete time, isn't it? The characteristic is what? Your CT signal is represented by xt and your DT signal is represented by xn. Now the thing is that your signal can be originally given in this form, or we can transfer, for example, our signal from a CT to DT. In your earlier courses, you learned how can we convert a continuous time signal into a discrete time one. Have you learned it in your communication or digital electronics?
Yes, sir.
By using sampling?
Yes, sir.
Okay. Now the thing is that we will be again discussing the thing, but let us consider this thing first, okay? Say we have a continuous time signal. According to our definition, if this is your t, this is your xt. If your signal is something like this, your time can be from minus infinity to infinity, that at any instant of, if we consider this time limit, for example, if our time is between t to t, then within this time interval, you will have many possibilities that your signal can be there. That means at every instant of time between this limit, you will have a value of your signal, isn't it?
Yes, sir.
Now, if we want to have, for example, if we want to convert this signal to this form, say in this form, let us consider that we have two time axes now. One is our T, another we are considering NTS. Okay, now what is NTS? Consider that we have a system that is taking an input xt and a switch is there. That switch is closing and opening at a rate ts, and we are getting an output there. Okay, so at time t equal to 0 we will have an output, at time t equal to ts you will have an output, at time t equal to 2 ts you will have an output, isn't it? What is the name of this switch actually? Is it not a sampler?
Yes, sir.
Yes, sir.
So the output of this sampler will be like something like this. So at n equal to 0, say, we'll have a value of our signal. At n equal to say 1, n equal to 1, that corresponds to ts. We'll have another value of the signal. At n equal to 2, that corresponds to 2 ts. We'll have a signal. At n equal to 3, we'll have a signal, that means 3 ts. Isn't it? Are not they the representative sample of your signal?
Yes, sir.
So this form of signal, we don't have any value between two successive time interval, okay? And these time intervals are equal, it is equal to ts. So a signal can be converted into a discrete form by using a technique called sampling, and the discrete nature of your signal will be equal to x and ts. And this type of figure we usually draw by using MATLAB or in any other technique. We call this quantity, the value of your signal, as a stem. So this is a stem figure. By using MATLAB, you can use this. In this course, your MATLAB will be the main thing, and your lab will also be conducted by using MATLAB. I am telling you from your first year that learn computer programming, particularly MATLAB. This is the integral part of your learning. Now the thing is, we are converting a digital continuous time signal into a discrete time one. Now in our representation, actually we do, in most of the cases in signals and system, the intermediate, for example, ts, 2ts, this time representation is omitted. As a result, what happened? Your continuous time signal is sampled to find this discrete time one, and it is represented by a sequence xn. That sequence will contain the value of your signal, for example, say from x minus 1, say this is your x0, say this is x1, x2, or something like this. Okay, that means a sequence of number will be there. So our n equal to 1, so if you want to draw the discrete time signal, then your diagram will be, this axis will be n, and this axis will be the value of your signal at the position of your n. Then n is called sampling index or a sequence number. So even it can be called as number of samples. So n equal to 0 is the 0th sample, n equal to 1 is the first sample, n equal to 2 is the second sample. Unless we know the rate at which the sample has been taken, we cannot convert our xn into xt or xnts. Now the thing is that either a figure can be given to represent your DT signal, or a sequence in this form can be given to represent your signal. But one thing you have to know in this regard, that when your xn is given, like something like this, that it is a sequence, say the value of your signal says this is 0.5, say this is -1, say this is 2, this is 3, something like this. So if you want to plot this signal, for example, this is your n. From where we have to start? This is n equal to 0. If you want to plot this signal, what other information you need to know? These are the value of your signal, say value of your x at different values of your n. Then if you want to draw the figure, what additional information you need to know?
What are the values of n?
একটু জোরে বলো।
What are the values of n?
The values of n is there 1, 2, 3, 4. That means you need to know from where you have to start.
Yes,
Okay?
sir.
That's for this reason, in many of your text, an arrow is put there, okay, beneath a figure. That indicates that this is your n equal to 0 point. Then right of this thing will be equal to n equal to 1, 2, and the left of your thing would be equal to n equal to minus to infinity, okay? So in this case, if your arrow is there beneath -1, then you have to say that at this n, this is what this value -1, this is n equal to 0. Then we have a value at n equal to -1 equal to 0.5. This point is n equal to -1, we have a value 0.5. Okay, then at n equal to 1, we have a value say 2. At n equal to 2, we have a value equal to say 3, something like this. In this way, you have to plot. So in this representation, an arrow is needed that will indicate the location of n equal to 0. And accordingly, you can find the positive and negative values of your sample number, and you can plot this. Okay, this is what the representation that we will be using in this text. So this everything I have discussed so far is already covered, and we will be because in order to equalize with other sections, we will be just going from this point ahead and a bit faster from your next class. Okay, so today's class I will want to close with by taking your percentage at this point. Okay. You have only 46 joined, but be careful about this thing. This semester will be conducted fully online. So your percentage will matter. If you have your problem with connectivity, try to get rid of it, and at least you just keep some alternative with you so that you can switch from your data to Wi-Fi. Okay, then when I will be calling your name, you have to